to understand this course. Okay, so basically the idea was that computing theorem. Okay, we want to find the limit of the function. Remember that computing theorems that we talk about it. So that computing theorem tell us that, the basic one was the operation like adding, subtracting, multiplying, and the notion of the limits of compute. But eventually we get one very important result, that is number 7, that we use for all our problems. And the result is that if you have a polynomial, and if you want to take a limit of the polynomial, you just substitute. So the exact value of the polynomial and the limit would be the same. So that will help us quite a lot. And all the examples that we did the other night will cover these type of ideas. Okay, give us an example of a polynomial. Make one.
4x squared minus 5.
And something is missing. Your notation is not good. What is the exact one? Anybody want?
4x squared plus 2x minus 1.
No, this is not a polynomial. It is, the way you talk about it, it's algebraic expression. You have to denote it as a function.
Oh, would it be f of x equals 4x squared minus 5?
That's it, yes. Yeah, that's give us a function format. Yes, you are right. Okay, as a function. Okay, so let's get back to those examples that we gave you. So we were some, we take those rational function. Remember the rational function 0, 0, but I finish it, then I come back to it again. Now, look at this last one that we did. You are going to give in 2 questions on this one. The last one was, this is a piecewise defined function. You see the function is defined by its partition around the 2. If you want to do anything, you want to find the limit of this function at 2, you can't do it right away, because this the equation of the function is going to be different when x is less than 2 or when x is greater than 2. So you have to find the one-sided limit, if you like. And this is exactly the way you've been asked to do it. So the limit of f of x goes to 2 negative. Remember, 2 negative means x is less than 2. So this means you are going to go towards the 2 from the left. So in order to find this limit, what we do is going to be what? So we say, oh, this x goes to 2 negative, so this means x is less than 2. So the function to be used is the first part. So you replace the f of x with the function, okay? You replace the f of x with the function, and then, okay? And then you just substitute. As soon as you get the function, this is a polynomial. A substitution give you the result. So this limit would be -2. Okay, so the left limit is -2. Then if you want to find the limit of f of x when x goes to 2 positive, okay, 2 positive means the direction from the right, because 2 positive means x is greater than 2. So when x is greater than 2, the function is 5x plus 1. You cannot use the first one. So as soon as you get the 5x plus 1, okay, as soon as you get the 5x plus 1 over here, then the rest is going to be just, okay, the rest is going to be just substitution. We replace the x by 2, we get the 11. Then from the right and the left, you have 2 different estimates. We talk about it. If you have 2 different estimates from the right and the left, this means the limit of the function when x goes to 2 does not exist, because they are different. You cannot fix it if you like. Okay, so the answer to the third part would be the fact that they are different, so the limit does not exist in this case. Okay, any question? Then they ask, what is f of 2? F of 2 is the exact, means you just go back to see where can you put x equal to 2. So x equal to 2 is coming from by the second part. So we substitute and you get the result. Okay. There are some other possibilities. So I'm going to give you another one to see. The other possibility is that you may find the right and the left limits, they happen to be equal to each other. Or you may try to find f of 2, and that would be impossible for you. So I'll give you another one. So we get this one right. Okay, so number 7. look at this one. This is going to be, again, interesting example. Suppose the function is given to in the following format. Okay, your function is f of x is equal to, okay, your f of x is equal to the, let's say, x squared. Okay, it's going to be x squared when x is going to be, let's say, less than 3. Okay, less than 3. And this is equal to the 5 when x is equal to 3. Okay, x is equal to 3. And this is going to be x plus, okay. And in this case, it's going to be x plus 6 when x is greater than 3. You see, this is your function. Again, this function is partitioned around the 3 here. Then they ask you to find the following. Okay, we would like you to find the same thing. It's partitioned around 2. So we'd like to find the first part. What is the limit of f of x when x goes to 3 negative? What is the limit of f of x? Okay, limit of f of x when x goes to 3 positive. And the third part, we want to know what's the limit of f of x when x goes to 3. And the last part, we want to find what is going to be f of 3. Okay, it's similar to the one that we talk about it. And then we are going to know, we are going to check this one. Okay, are you ready? For each part, you read the function, you bring the proper function, you substitute to get the result. So the solution is going to be, that's it, limit of f of x when x goes to 3 negative is equal to, now, again, x goes to 3 negative. What does it mean?
3 to the or to the left.
Okay, so x is less than 3 or greater than 3.
Mm-hmm.
Less than?
It's going to be less than, yeah. X, you see, x goes to 3 negative means x less than 3. That's what we need. When x is less than 3, the function to be used is the first part. So you are going to write the limit of x squared when x goes to 3 negative. From now, it's just a substitution. This sign on the top is just a direction. It's not negative sign. So we just substitute 3. It's going to be 3 squared equal to the 9. So this is going to be the left limits. That's part 1. Any question? It's the way you write it down. You talk to yourself. You say, oh, x goes to 3 negative means x is less than 3. When x is less than 3, I have to use the first part. Read it carefully. On the test, they may switch it. They may give you 3 positive first, 3 negative next. Okay, so make sure that you get the you get the correct one and don't be confused. So we go to the second part. In the second part, we want to find the limit of f of x. Okay, when x goes to 3 positive. Again, x goes to 3 positive. You know that it means from the right. From the right means x is greater than 3. When x is greater than 3, the function to be used is x plus 6. Okay, so it's going to be equal to the limit of x plus 6. X goes to 3 positive. So from now, it's just a substitution. It's going to be 3 plus 6, which is equal to the 9. That's it. So the right limits and the left limits happen to be equal to each other. You know that if the right and the left are going to be equal to each other, so this means the limit of the function when x goes to 3 does exist, and this is also equal to the 9. So this is how we're going to explain it for us. You say that, oh, the limit of f of x when x goes to 3 negative is equal to limit of f of x when x goes to 3 positive and is equal to the 9. You have to explain it. Okay, so that would imply that the actual limit of f of x when x goes to 3 is also equal to the 9. Any question? You see the previous one.
Professor, I had a quick question.
What's that?
What if they didn't equal to 9? Would we say the limit does not exist?
What
If
is
they
that?
both-
If they
if they
they are
both
going
didn't-
different, then the limit does not exist.
Okay, gotcha. Thank you.
Like the previous one. You see this one? You
So
see -2 and
one-
11. So
1
they
and
are,
2 have to equal each other to get to the third one, like the third question.
of course, yes.
Okay, okay.
See if they are, because you estimate it, you see? You're estimating the values. When you estimate it from both sides, you must arrive at the same number. You see here? The numbers are different, so the limit does not exist. But if the numbers are equal, so this means the limit does exist, okay? So if you get the equality sign here, that would carry to the limit. But if you don't get it here, you won't get it the other side. Okay, so this is the second possibility. Any question? So that's a number 3. Number 4, we want to know what's the actual value of the function. What is f of 3? So this means where can you put x equal to 3? Not with the first one, because there is no equality sign here. Not with the third part, because there is no equality sign here. It is here. When x is equal to 3, the function is 5. So f of 3 is equal to 5, and then you're done. Okay, I'll just give you various possibilities for the piecewise defined function. These type of examples are very important, and you have all the possibilities here. Okay, any question? So you have only 2 possibilities. You see the number 6 and the number 7 that we have. Okay, let's see what's going to be the next example. You see, look at these 2 examples that we did. Sometimes, as you see over here, the right and the left limits are the same, so we get the limits, or sometimes they are not, like the previous one. So there is going to be a collection of problems that they want to force the function so that, okay, sometimes you may change the problems, change the function, so that you get this final answer. This is a kind of a converse problem, if you like. So what's going to be the converse problems over here? You see, again, a function would be given to you. So this is going to be number 8. And you have all of them on that practice one that we're going to check it. And the take-home one. So what's going to be number 8? Look at this one. The number 8, suppose we have the following function. Okay, suppose your f of x is equal to f of x is equal to the, let's say, 3x squared, okay, minus m times x, m times x plus 1. This is the value of the function if your x is going to be less than 1. Okay, it's going to be less than 1. And then you have another one. The other one is going to be 5mx minus 3 if x is, okay, greater than 1. So the function is given to, there is an m here. Okay, so what we would like to do is, if we would like to find, you see, we ask you to find a value, or the value of that number of the constant m, we call it, the unknown constant m, so that, or such that, or so that the limit of the function, limit of f of x, okay, let's say when x goes to 1 negative, would be equal to the limit of f of x when x goes to 1 positive. That's it. Okay, in the previous problems, you did find the right and the left limits, and you did check to see if they are equal or they are not. But they put the m here. They want to guarantee, okay, they want to guarantee that these 2 limits are going to be the same. So there is an m here. We want to know for which value of m this situation would happen. Okay, so that's going to be the question. It's kind of converse problems to the given one. Okay, let's see what you want. You see, you have one unknown. Your unknown is m. In order to find the one unknown, you need one equation, okay? You need one equation to be able to find your, okay, to find your unknown, if you like, to get these numbers, okay? So if you can find one equation in terms of the m, then you solve for m and you're done. So what is that equation? It's already given to you, see? You'll be given that find the m with this condition, the condition that the left limits and the right limits happen to be equal to each other. So what you're going to do is, you're going to find the left limits and you're going to find the right limits. You let them equal to each other. As soon as you let them to equal to each other, that's an equation you solve for m. Okay, very easy procedure. So you want to find the m so that these two limits are the same. So find it. Find these limits, okay? Find the right and the left limits. And in practice, in calculus, anytime you see a piecewise defined function, anytime, you just find the right and the left limits, then that would be useful. You see, you may get 50% of the grade of that question without knowing anything else. But in this case, we know that. We are going to find them, okay? So find these limits. You find the limit of f of x goes to 1 negative. Now we know it. X goes to 1 negative means x is less than 1. When x is less than 1, the function to be used is the first part. Okay, so it's going to be equal to the limit, we bring it, limit of 3x squared minus mx plus 1. Okay, when x goes to 1 negative. Now from now on, it's just a substitution. You put x equal to 1. So x equal to 1, that gives you 3 minus m plus 1. You simplify it, so that gives you negative m, okay, negative m plus 4. So this is going to be your left limits. Okay, your limits, you know, it contains m, it's okay, because we are going to find the m. So this is the left part, if you like. Find the right part, and then let them equal to each other. Okay,
Where
so
did you get,
what's that?
where did you get the 4?
3
How
and
did
1,
you-
4. You combine the like terms. 3 plus 1, 4. Okay. You substitute, then you simplify it. To simplify it, you combine the like terms. The like terms, you get the negative m, 3 and 1 would be 3 and 1 would be 4. Okay, so this is going to be the case. What happened to the x? We substitute. There you are. X goes to 1. You replace the x by 1. Okay, to get this number. If you want, I can explain it for you. It's a 3 times 1 squared minus m times 1 plus 1. 1 squared is 1. 1 times 3 is 3.
So do you
Minus m.
always put 1 into the x spot or whatever the x equals at the top?
Of course, limit, you see. Remember how we're going to find the limit when x goes to 1. Look at this one. X goes to 3 negative. You substitute to get these numbers. Okay. So you substituted in this case, there is an m. Okay, that's m. Doesn't matter. You find the values. Okay, so this is going to be the left limit. Find the right one. What's the right one? Limit of f of x. X goes to 1 positive. X goes to 1 positive means x is bigger than 1. When it's greater than 1, the function to be used is the second part. So it's going to be equal to limit of the function to be used is 5mx minus 3. When x goes to 1 positive, that positive is just a direction. You substitute for x is 1. So it's going to be 5m times 1 minus 3. So that gives you 5m minus 3. You see, that's why. So the right limit and the left limit is negative m plus 4. The right limit is 5m minus 3. But you'll be given that find the m so that they are equal to each other. So let them to be equal to each other. Okay? Let them to be equal to each other because you need a condition. You need the condition to be able to find the limits. So let them to be equal to each other. So you have a negative m plus 4, and this is 5m minus 3. Solve for m. How are we going to solve for m? It's a negative m, you subtract negative m minus 5m equal to negative 3 minus 4. So negative m and negative 5m would be negative 6m. Negative 6m equal to negative 3, negative 4 would be negative 7. So m is equal to, what is that? Negative 7 divided by negative 6, which is 7, 6. That's it. So this means if you go back to the function and you replace the m by 7, 6, and if you find the right and the left limits, both of them happen to be equal to each other. So you identify the values for each, okay, to get these numbers. Okay, so this is going to be the one. So what is your question? That is going to be the case. Okay, so this is a very, very popular method or techniques that we're going to use, and we're going to use it in some other places too. And you have a couple of them in your book. Okay, so this is a converse of the previous one. So in the previous one, everything was nicely given. There was no m. Okay, there was no m, and you just find the limit of the function. So you're just doing the usual thing. Okay, you identify which part are you going to use. Okay, the part 1 or the part 2, and you just substitute and you get the result. But over here, we want to make sure that the limit of this function does exist. You see, that's what we are aiming for. So we have to find the m so that the right and the left limit are going to be equal to each other. So we're going to find them. You see, limit of x when x goes to 1 negative, we know that this means x is less than 1. When x is less than 1, this is the function to be used. Okay, you substitute for 1 as usual. You substitute x equal to 1. You simplify that, give a negative m plus 4. So that's going to be the left limit in terms of the m. You do the same thing to the other parts, because this is the way you do it for all the problems. Limit of f of x, x goes to 1 positive. You substitute, simplify it, so that gives you 5m minus 3. But since they are given that they are equal to each other, you let them be equal, so for m. So you need the m to be 7, 6, so that the right and the left limits happen to be equal to each other. Any question? So I've given this problem several times. Most of the people, they do this type of solution. I'm going to write it down for you so that you are not going to write it down on the quiz, okay? So let's see what is wrong. Any question on the solution that I did? Right, left limits, let them equal to each other. As soon as you let them to equal to each other, you get an equation. You solve that equation for m, and then you get your answer. Okay, let's see what's going to be the wrong solution. Okay, don't do it. What's wrong with this solution? Okay, let's see. What is wrong with this solution? Same problem. You see the way they do it on the test, or you may do it on the test. They start from it. Look at this part of the function. They start by letting the first part and the second part to be equal to each other. You see, this is the way they do it. They say, oh, 3x squared minus mx. Okay, the first part, mx plus 1. They let it to be equal to what? They let it to be equal to the 5mx minus 3. That's the first step. Then they replace the x by 1. They say x is equal to 1. So if you put x equal to 1, that gives you 3 minus m plus 1. And that would be 5m minus 3. Then they solve for m. You know, 3 and 1 would be 4, so that gives you negative m plus 4, combine the like terms. And that would be 5m minus, okay, minus 3. Then they subtract. It's a negative m minus 5m, and this would be negative 3 minus 4. So that gives me negative 6m equal to the negative 7. So m would be 7, 6. The same solution. I say the same answer. 7, 6. But I give you 0 out of 4 if you do this one. What's wrong with this one? Any suggestion?
I feel like for this one, they didn't explain where the x's went.
No.
Are they assuming that both functions have all values in common? Which is essentially not true, because for 3x squared minus mx plus 1, the values must be less than 1.
Yes, yes, somehow you are very close.
And then for
Very
the
close.
other function, they must be greater than 1. So they're like considering the value of 1, I suppose. As
Yes, let me just repeat the question. Somebody asked what is the question. You see, the question is what is wrong with this solution? That's the solution. You see, let's read the problem again. So what was the problem? Problem
that
is
they didn't write the limit of f of x equals.
Of course, you see, read this problem again. You want to find the value of the m, so the limits happen to be equal to each other. The limits. You see the way I did it? I find the limit first, and then I let them equal to each other. So in this solution, where is the limit? You see, in solution, where did you use the limit? That's it, yes. You see? And you was right that they let the function to be equal to each other, which is not true. The limits are equal to each other. Since this function is a kind of polynomial types, that limit and the value of the function happen to be the same. So it's a coincidence that you get the same one and you just continue to get the 7, 6, okay? So if you do this solution, we put the question mark on it and we ask you where is the limit? Okay, where is the limit? So the limit, you didn't use the limit. Okay, so don't do it. Find the limit first, then you let them equal to each other. You can correct it if you like. If you want to correct it, you have to put the limit here. This is the limit when x goes to 1 negative. And this is the limit when x goes to 1 positive. Then the rest would be true. Okay, but I prefer this method. You find the limits first. Okay, this is it, as is. You find the limit first, okay? Limit first, then you let them equal to each other. That makes sense, okay, to get these numbers. Okay, the people argue that I got the same solution. Yes, you get the same solution, but your solution is not the solution of this problem. Because in this problem, the condition is that the limits are the same and you didn't use the limits, okay? So it's a very nice procedure. Be precise, okay? Mathematically, logically, your solution must be a standard one. Okay, any question? We have to in the practice one, we check it. So it's a easy problem, but you have to write it down correctly. Okay, so that is one version. There is one more problem. And then we can go and review those quiz, and then you can do the take-home one for yourself because they are very similar and would be similar to what you are going to see on the quiz. Okay, so what is this last problem? This last problem is also interesting, and you have it in your assignment. Okay, so this would be probably one of your questions that you don't do it. Number 9. We want you to find an issue. You see, this is going to be, let's write it down. Would like you to find each limit. Again, it's a very easy limit, but we are going to use it in future. So we want to make sure that you know it. So what is this limits? The first one. Okay, the first one is limit of. Okay, it's a limit of the absolute value. of x minus 5 divided by x minus 5 when x goes to 5 negative. That's the first one. The second one, what is the limit of absolute value of x minus 5 over x minus 5 when x goes to 5 positive? And the third one, they may give you just one of them, of course, but we are going to be prepared for all the possibilities. Absolute value of x minus 5 over x minus 5, x goes to 5. You see, that's a very popular limit in calculus. Let's see how we're going to do it. Now, first, just remind you the notion of the absolute value. You know that the absolute value is your distance from the origin, if you like. And the absolute value is always positive. So just remind you this one, okay, for the solution, just for your information. Recall, if you like. Recall that the definition of the absolute value, if you like. You see, if you want to find the absolute value of something that I call it u or z. So this absolute value of u would be the same as the u if u is positive. Okay, absolute value of 5 is 5. Absolute value of 7 is 7. Okay, if it's going to be positive. It would be 0 if u is equal to the 0. Because the absolute value of 0 is 0. It's going to be opposite of the u, means a negative u. If u is negative. If u is negative. Okay, the absolute value of negative 5 would be opposite of the negative 5. Opposite of the negative 5 is a positive 5. Okay, because the result of the absolute value must be a positive number all the time. You see, that's why when it's a negative, we put a negative over here so that the double negative make it into the positive. Okay, so for example, I just remind you the absolute value of 6, so it's going to be equal to the 6. But the absolute value of, let's say, negative 9 would be opposite of the negative 9. Opposite of the negative 9 would be 9. And if you like, it's going to be negative 9, which is going to be 9. And the absolute value of 0 is equal to the 0. Okay, so just make sure that we are ready and we are happy about the definition of the absolute value. Any question? Let's go to the problem. This one. Okay, the difficulty with the problem of the absolute value in calculus is you have to take care of this absolute value first. So you may call x minus 5 u. So you have to check to see which of these two is. Can you drop the absolute value, consider only u? Or if you drop it, you have to pay for it. You have to consider the opposite of u. So it depends on the nature of the limits. So what is going to be the limit that's going to be interested in? Okay, so let's take the first part. You want to find the limit of the absolute value of x minus 5 over x minus 5 when x goes to 5 negative. You have to check to see what is going to be this absolute value. Okay, absolute value of x minus 5. Okay, x goes to 5 negative. What does it mean? What's the meaning of x goes to negative 5 or 5 negative? Come on.
It's going to the left.
It's going to the left, which means what is the relationship between x and the 5?
It's less than 5.
Yeah, always use this one. I mean, we know that the left, but x goes to 5 negative means x is less than 5. That's the meaning of x goes to 5 negative, okay? Give us a number less than 5. 3. If you substitute 3 over here, what's going to be the result?
2.
It's going to be 3 minus negative 5 would be a negative 2. And you know that the absolute value of negative 2 would be opposite of the negative 2. Opposite of the negative 2 would be negative 2. Okay, so basically, since you use the number less than 5, inside is going to be negative. Okay, so if you pick something like 4.5, if you replace x by 4.5, 4.5 minus 5 would be negative 0.5. So you drop the absolute value and use the negative sign. So basically this means when x goes to 5 negative, inside the absolute value is negative. Look at this one. Inside is negative. When the inside is negative, you drop the absolute value, but this result would be opposite of the inside, opposite of the u. Okay, I explained it on this line so that you don't have to, for the solution, you remind yourself, so oh, x goes to 5 negative means x is less than 5. So it's a 4, it's a 3, it's a 2, it's 1.5, 3.5. So whatever I pick, this inside is a negative number. So the absolute value of x minus 5 is going to be, you see, u is negative. So the result is a negative u, is the opposite of the x minus 5. You see, that's the meaning that you're going to have. So this means if you want to find the limit, you can drop the absolute value. So it's going to be equal to the x goes to 5 negative. So the top, you drop the absolute value, you pay for it, opposite of the x minus 5. And the bottom one would be x minus 5. You see, common factor. Simplify it. You simplify this one by x minus 5, that give you 1. This one, that give you negative 1. Negative 1 divided by positive 1 would be negative 1. So the limit would be negative 1. Any question? You see, this is the way you judge the absolute value. So you have to make sure that what is the sign of the inside, that x minus 5, when you replace x by the numbers. Since x goes to 5 negative, you are allowed to use only the number less than 5. So any number less than 5, make the inside negative. You see, any number, because it's a 5. Okay, so since make it negative, you drop the absolute value, but the result would be opposite of the u, which is going to be negative u. Okay, negative x minus 5. So negative x minus 5 on the top, positive x minus 5 down the bottom. You simplify it, so the limit would be negative 1. Okay, so this is going to be, no, on the quiz, this is exactly how we're going to write it down for us. You can drop these, but if you just give us negative 1 right away, we put a question mark for you, because you have to explain it. Okay, we don't want you to memorize anything. You have to explain it to get these numbers. Okay, so why not? You know it, write it down nicely. Enjoyed it. Okay, any question? How about the next one? Second one. X goes to 5 positive. Let's see what's going to be the difference. Limit of absolute value of x minus 5, x minus 5, x goes to 5 positive. Then check to see what is the sign of x minus 5 now. Give us a number. You know that x goes to 5 positive means x is greater than 5. So give us a number bigger than 5. Number, try.
6.
Number bigger than 5. Yes, 6, 7. How about 5.1? Number close. Okay, 5.1, 5.2, 5.3. Yes, we can get 100. It doesn't matter. If you pick all those numbers, you see, because you see, x goes to 5 positive, you over the 5. So, for example, if you pick 6, 6 minus 5 would be positive number. You may say, oh, 6 is too much. Okay, 5.1. If you pick 5.1, 5.1 minus 5 would be positive 0.1. Okay. If you pick 7.2, the result would be 2.2. So when you're going towards the 5 from the right, since all your choices are going to be bigger than 5, so this x minus 5 would be always positive. If the inside of the absolute value is positive, you just drop the absolute value. So the conclusion is going to be, if you want to write down in that format, it's just for your information. You don't have to write down on the test. You say, oh, x is greater than 5. Greater than 5, this means x minus 5 is positive. That's it. That's what we mean. So the absolute value of x minus 5 would be the same as the x minus 5. because whatever I put for the x, the result is positive because I'm over. So that limit would be changing to what? So this is going to be equal to, this is just equality sign. Okay, so you are going to end up with the x minus 5 on the top and the x minus 5 down the bottom. When x goes to 5 positive, you simplify it. 1, 1 equal to 1. It's a very
Professor, I had a
unique.
quick question.
Yes.
On the quiz, can we just plug in the numbers to show our work, or did you want us to do in that exact same format that you're
No,
doing
you
right
don't
now?
need, you don't need to plug the numbers, no. You mean those 5.1, 5.2 that I talk about it? Those numbers you mean? No. No, you don't need it. You need to take care of the absolute value first. Okay, so it doesn't matter which number you put. We don't write the numbers because when you do just a couple of numbers, that would be just a specific number. You see, then you'll be in trouble because you have to give us something general. You can pick those numbers for yourself to make sure that what are going to have. Are you going to have the first case or the second one? Okay, and this is a very typical problem. It's not going to be changed much. It's x minus 5, you may get x minus 2. Because if you change it, the result's going to be easy problem. You see, the difficulty is if you substitute the 5, you know that this is 0, 0. Remember, when you get the 0, 0, you must have a common factor on the top and the bottom. So that's why you take care of the absolute value, then you get your common factor. You take the common factor, you eliminate the common factor, you get the negative 1. You eliminate the common factor, you get a positive 1. That's basically the idea. But we just want to make sure that, you know.
Oh, so we just have to show this like 1 and 2 work.
Yeah, that's fine.
Oh, gotcha. Okay.
Okay. Any question? What's the answer to the third one? What's the limit when x goes to 5? Any suggestion?
The limit does not exist.
That's it. You see, even this part is given to you. You can't do it right away. Because when x goes to 5, you know that x goes to 5 means x is not equal to 5. So x can be less than 5 or greater than 5. So even if this is given to you directly, as in one of the problems in your assignment, you have to do the right and the left. You have to do the right and the left, and you see that they are not equal to each other. So since they are not equal to each other, so this limit does not exist. Okay, so part 3, this is the way you are going to answer it. As we did it for the other one. You are going to tell us that, oh, the limit of absolute value of x minus 5 over x minus 5 when x goes to 5 positive is not equal to the limit of absolute value of x minus 5 over x minus 5 when x goes to 5 negative. Because one of them is 1, the other one is a negative 1. So this means the actual limit does not exist. Okay, the limit of x minus 5, absolute value of x minus 5 over x minus 5 when x goes to 5 does not exist. The reason that we study this one, there is a kind of one case, we call it a counterexample. Later on in the next chapter, that we have to justify it with the absolute value. Otherwise, you are not going to use it. Okay, but it's a very nice example. Okay, so you got to be careful. If they give you just one of these, this is the way we do it. We want to check, you know, if you can do it as a single format. So if just one of them would be given to you, you are ready for it. X goes to 5 negative is negative 1, 5 positive is possible. But if the third one is given to you, you have to do the one and this, you know, the first and the second, then you get to the third. It's going to be a bigger problem, if you like. But you should be fine. Absolute value in calculus is the red flag. Anytime you see the absolute value, there is something about it that you have to take care of. We have one in the practice one. I'm going to do that one for you too. Okay, any question? So these 9 cases are all the possibilities that you are going to have in this section. If you can do this type of problems for us, you'll be fine. not only in this chapter. The next concept, 1.6 continuity, is just a definition. Then this one. When we get to the chapter 2 again, these same procedure are going to be used. So that's why we slow it down, make sure that everybody's happy about this procedure, and then we go on. Otherwise, it would be difficult to get through it. Okay, question? So we go to the practice quiz and we do all of them. Then you should be able to do the take-home one for you, okay? So we give you 6 sets of questions as we talk about it. We give you one question on the domain of the function. Let me just, this is the one that I posted for you. So this is the way we are going to operate. When we get the test, there is going to be a practice test again. So I do the practice test, and there is going to be a take-home one for that test. So you do the take-home one, okay? If you want a good, good practice, if you like. So that's a take-home practice one that I posted. So I'm just going to show you once because I cannot keep it all the time. So this is going to be the one that we are going to do. And just make sure you use, it's on the, on the canvas. Can you see it?
Yes.
Very good, that's it. So as you can see, the first problem is the one about section 1.4. We want to find the domain of the function. We have kind of 7 types or 5 types of function, and we give one from each. This is in fact what you are going to learn in section 1.6, that although we are not going to cover it, but we already covered everything we need. So after your quiz, you just give me one definition and then you repeat these problems again. Now I ask you to find the domain of the function. Then we ask you where these functions are going to be continuous. Then it's going to be the same question, okay? So this is going to be 1. So number 1 and 1 to number, this is number 1 and number, there must be one sketching the graph of the piecewise defined function. Let's see if you have it. Should be 1. Yes. Number 1 and number 3, if you like. And number 3, part 1, because we want to sketch the graph of this function. This would be the review that we did. And then the rest are going to be just the limit of the function, okay? So I'm going to go to my notebook and I keep this for myself so you know what I'm talking about. I just give you one from this. Okay, let's see if I can get this one. Okay, so I stop this one. I go to the notebook, and as I do it, if you have any question, you let me know, because you are going to have them in quiz 1, test 1, and on the final exam from the first part of the course, you'll be given 2 questions only, and those 2 questions coming from this practice quiz. Okay, so keep the solution and pay attention, because you are going to use them over and over and over. Okay, so let me just bring that practice one for myself so I can see it. Okay, I want to move it to my other monitor. Okay, are you ready? That's it. Practice quiz number 1. Practice quiz number 1. Okay, number 1, the first question. The first question, you want to determine the domain of each function. Remember, we talked about it. Determine the domain of each function. Domain of each function. 5 different types. Type 1, part 1. Part 1, remember the domain is, the function is mathematical machine, X is a free agent. If there is no restriction, the domain is all real numbers. If there is a restriction, like, dividing by 0, taking the square root of a negative number, you have to take care of it. Okay, solution of the first one. You see, we talk about it. X is a free agent, means X can be any real numbers, except where the operation of the function would put some restriction on the X. You check the operation that you have. You have addition, subtraction, and multiplication. So you can add, subtract, and multiply any number you like. So there is no restriction on the X. X can be any number. Since X can be any number, so the domain of the function is going to be all real numbers, or the number line. Negative infinity and positive infinity. That's it. What type of function is this one?
Polynomial.
Polynomial.
Polynomial. So the best way to write it down is this. F is a polynomial. F is a polynomial and the domain, all real numbers. You have to, you better mention the polynomial, get used to it, because we need it for the, for the end, for the rest of the course. We accept, we like interval notation. You can use, if you like, even you can use D equal to the R, all real numbers, and be done. That's a group 1, type 1. Any question? So remember, the polynomials are the best function in calculus because there is no restriction and they are defined everywhere. Any question? Yes.
Yeah, I have a question. For the quiz, do we have to mention what type of function the given is, or would that be part of like what we're graded on, or is it just good to?
For the polynomials, you have to tell us.
Oh, okay, just for the polynomials.
Yeah, because the polynomial, you just say its domain is all real numbers, so why?
Oh, okay.
Okay, yeah.
And for the other ones where we do have restrictions, we wouldn't have to mention it.
No, automatically we'll see that you impose those restrictions.
Oh, okay, yeah.
But this one, we are sensitive, you see, polynomial. Because we want to repeat this one so that you know it. Because it's going to be used in any sections, okay? Any question? And this is just the beginning. We put some restriction to show you how to be nice, okay? Write this expression nicely. And then, when we are done, then we can do more, better one. Okay, this is it. Yes, this is exactly how you're going to write the solution for me on the quiz. Okay, any question? That's type 1. Are you ready for the type 2? Type 2. The type 2, of course, rational function. G of x equal to G of x equal to the 3x plus 1 divided by x squared plus x minus 2. You see, the extra operation is division. When we get the division, there is a restriction, of course. Okay, so the solution is going to be, so you get the free agent of A. These are optional, but I like to denote it. Since you have the division, you know that you have to make sure that the denominator is not 0. So you are going to find out where the denominator is going to be 0. Since it's x squared, you better factor it first, okay? So that's going to be your job. G of x is equal to 3x plus 1. You factor this one, you know that this is going to be x times x. So what you need, this is a negative, so this is a product of two numbers. Since negative, this is a difference. So 1 is a difference. So you want to find two numbers with a product of -2 and a difference of 1. Any suggestion? Two numbers with a product of 2 and a difference of 1. Give us 2
and -1.
That's it, 2 and 1. So I start with the bigger number. This is the sign of the bigger one. So it's going to be x plus 2. So the second one must be x minus 1. That's the quickest way to find it. Okay, so if it's a negative, this is a difference of the numbers. If this is positive, the coefficient of the x is the sum of the numbers. And this is the sign of the bigger number all the time. So it's a 2 and 1, so that must be x plus 2 times x minus 1. Okay, now you let the denominator, you see now the denominator would be 0 at what? The denominator would be 0, you see if you want it officially. So the first one give you x equal to the -2. The second one give you x equal to 1. So these are the restriction that you're going to have. So this means x is not free agent anymore. This is a negative infinity and positive infinity. So you have to remove these bad numbers. So you're removing the -2, and then you're removing the 1. So this is where your function is defined. So this is what's going to be the domain of your function. You partition the number line into 3 parts, 1, 2, 3. So the domain is, you start from here, you start from -infinity up to the -2. You have to use parentheses because you removed it. Use bracket if it's still there, if you like. Then the second portion is going to be union bit. You get the -2 and 1 again. Again, open parentheses because you removed it. And that the next portion is going to be 1 and positive infinity. This is the domain of the function. Very popular function to get these numbers. Any question? You see, it's a rational function. It's a rational function because the denominator contains, you see, containing the x. So you have to find the values where the denominator is 0. So we're going to find it since x is squared, you factor it. You have 2 factors. 2 factors, 2 numbers. So the numbers to be out is a -2 and 1. So 1, 2, 3 portion. And this is going to be the domain. Yes, what's the question?
So do we have to test it out like how we did with the other ones? Or we see if it's positive or negative or positive or negative in each
What
section,
do-
or can we just write?
No, no, no. Why you test it? No. You don't need any testing.
Okay,
It's just the
Thank you.
domain of the function, you see. The only difficulty is you must make sure the denominator is not 0. Okay, it's not 0, so you let it equal to the 0 and you find those bad numbers. Okay, the exceptional one, if you like. Okay, question? So factor the denominator if you need it, and then you find out which numbers are the one that you have to remove if you like. Okay, so this is that was the part B, the rational function. Let's get the rational number function. You have different cases. We just give you just one. So how about the next one? The next one is h of x, which is equal to x minus 4, x squared minus 16. Again, we have, okay, this is a rational function again. So you have to make sure the denominator is not 0. So find out for what value of x, the denominator would be 0. Any suggestion?
What was the question?
For what value of x, the denominator is 0. Yes, Paul, you are right. Numbers? You can factor it if you have it. You are uncomfortable about it. X minus 4. You factor this one into the x minus 4 times x plus 4. See, that's it. So you have 2 factors. So this is x minus 4 times x plus 4 equal to the 0. So we get 2 numbers, x equal to 4 and x equal to the -4. So the denominator would be 0 at 4 and -4. You see, 4 squared 16, 16 minus 16, 0. -4 squared 16, 16 minus 16 is 0. So this is the number line. You have to remove 2 numbers. You remove the -4 and you remove the +4. That's where the function is defined.
Couldn't you
1, 2, 3.
factor out the x minus 4 from the top and bottom?
What's that again?
Couldn't you factor out x minus 4 from the top and bottom before even figuring out the domain?
No, you can't do that. You can't do that. That's why I give you this one to see if you are going to make that mistake. You see, because why you can't do it? You see, if you do it without the domain, so this is what you mean. You mean to canceling these two out. But remember, if you want to cancel it, you must make sure that this is not 0. X minus 4 would be 0 when X is equal to 4. If you don't give us a domain, how do you know that X is not equal to 4? You see, that's your difficulty. Okay, so if you want to simplify it, you have to simplify it at the bottom when you identify the domain. Because without domain, you don't have anything what you are talking about. Because this is a function, it's not algebraic expressions. In algebra, you do it. But in this case, the function would be identified by its domain. So that's why I give you this one. Most of the people, they simplified here. No, you've been asked, what was the question? The question is, what's the domain of the function? This function would be defined if the denominator is not 0. So you have to exclude the values of the X that make the denominator equal to 0. Those values are -4 and 4. Okay. In the case of the limit, remember we simplify it because that was the limit. When X goes to 4, remember this means X is not equal to 4. So that's why you are able to simplify. Okay, so if you want to do anything to a function, you have to find the domain of the function first. Okay, now, so what's going to be the domain? Read these portions, 1, 2, 3. -infinity up to the -4. Parentheses, you don't use bracket, union with -4 and 4, union with 4 and positive infinity. This is the domain of the function. Any question? You know, you haven't been asked to simplify it. So if you want to simplify it from now on, you put it here. Here, you factor out, you know, you divide out by X minus 4, your function would be 1 over X plus 4. But if you simplify it at the beginning, then you say, oh, the numerator is just X plus 4. So I remove only -4. You see, your domain would be quite different from the actual domain of the function, because if you simplify it, you are not going to have the 4. So this is, you claim that's going to be domain of your function, which is not correct, because the function originally was here. Okay, so that's why I give you this problem, just to compare. Okay, any question? That is a part C. There is another one for the rational functions. These are all the possibilities, and we give you only one of them. It's nice to have all of them, just to repeat it. Okay, what's the part D? Let's see what is special about this one. The function is f of x equal to, okay, the top is x, the bottom one is x squared plus 9. You see that's one. So you have x squared plus 9, you should have to try to see if you can factor x squared plus 9. Okay, can you factor x squared plus 9? Factoring x squared plus 1, is it possible? No, it's not possible. Okay, no, you cannot use 3 and -3 because this is plus 9. Okay, when it's a plus 9, you are not going to be able to factor it. Your plus or -3 in this case is not true, because a 3 squared would be 9, 9 and 9 would be 18, so you won't get the 0. If you say -3 squared would be 9, 9 and 9 would be 18. So when it's a plus, x squared plus 9 is not factorable. When it's not factorable, there is nothing to be removed. So the domain of this function would be all real numbers. Okay, so that is the difference. Make sure you remember it. So this is how we're going to answer this question. You're going to tell us that, oh, x squared plus 9 is not factorable. You cannot break it. If you cannot factor it, so this means it's never 0. It's impossible to find a number that make this denominator to be equal to the, okay, to be equal to the 0. That's it. So there is no restriction, you see, because we couldn't find any factor. So the function, the domain is all real numbers. and then you're done. Okay, so these are all the possibilities when you're dealing with a rational function. Any question? So that's the second class of the function. We have a third one. Remember, the third one is a radical function. So let's check the radical one. We have the part E. This is it, part E. So the part E, your function is g of x. Okay, g of x, which is the square root of 9 minus x squared. Okay, we talk about it. When it's a radical, if you take the square root, okay, the fourth root, the sixth root, the eighth root. So if the index of the radical is even, there is a restriction. Restriction is you cannot find the square root of a negative number. So you have to guarantee that this is a positive number. If the index is odd, cube root, fifth root, seven roots, its domain is all real numbers. Because in the case of the cube root or the fifth root, there is no restriction. So you got to focus on the index of the radical. Index is the number that you put here. When it's a square root, the index is 2. So this is how we're going to explain this one. Okay, you explain that the index of the radical 2 is even. Then you'll be in trouble. Since it's even, and so g, or g of x, is defined when or where 9 minus x squared is greater than or equal to 0. You see, that's a restriction. You cannot have a negative number. Now you have to solve for x. We talk about how we're going to solve for x. We move the 9 to the other side, we subtract. This is it. Since it's a negative, I multiply both sides by a negative number, -1. If you multiply the terms of the inequality by a negative number, remember you switch the sign. So this is it. If you like, multiply by a -1. So that makes this one into a positive number, x squared. And that's a graded one is going to be less than or equal to. And this would be 9. Okay, we're just solving the inequality. Then you take the square root. Okay, I told you that the radical x squared would be absolute value of x. This is going to be less than or equal to 3. So your absolute value is your distance from your home, if you like. So absolute value of less than 3, this is the way we talk about it. This is going to be the origin. So this is 3 miles from your home from the right, and the 3 miles from your home from the left. X is less than 3. Less means inside. Less inside. If it's going to be greater than, you go outside. Outside to the right or outside to the left. This is the domain. -3, domain is -3, 3. But you have to use bracket for both of them. Because you see, because x can be equal to 3. It's equal to. If you put x equal to 3, that the square root would be 0. So in the case of the radical, you have the bracket. But in the case of the rational function, you are going to have a parenthesis. Okay, so we are interested in this type of the radical function because this is the one that we're going to use in future. Yes, what's the question?
So if it was greater than, how would we write the domain?
Greater than, you are going to have the portion to the right and the portion to the left. Would be negative infinity up to the -3, union with 3 and positive infinity. We have one. The next one is the one that we get greater than.
Oh, okay, thank you.
Okay, so that's a very important question. Okay, this is going to be one. How do you know that it's an absolute value? We talked about this one the other night. Okay, the radical x squared, you see, I told you that radical x squared is equal to the absolute value of x. Why? Because the square root must be a positive number. Okay, so to guarantee that it's a positive number, you have to use the absolute value. Some people, they say it's equal to the positive negative x, which is wrong. The result is one number, and that number must be positive. So that's why you put the absolute value to get this numbers down. Okay, any question? Let's get the second one to see that what would happen if it's going to be the other way around. That's a part E, part F. I'm going to change this part F because it's a square root again. Okay, so let's call it, so that you have all the possibility, call it the fourth root. Okay, it's going to be the same solution, but that give you a better idea. Okay, we can change it to the 4. Because I want to see that if the index is even, you are going to do this type of operation for us. Okay, are you ready? You see this number, index is 4. Solution. The index is equal to the 4, it's even, so you'll be in trouble. And the function k or k of x is going to be defined when or where this expression x squared minus 2 is greater than or equal to the 0 again. Now you solve this one.
What happens if the index is an odd number again?
You have to wait.
Oh,
When it's odd, we have nothing to worry about. You see? Because the odd, you see if it's going to be odd, we can take the odd root of any number. So the domain is all real numbers. Okay? Because for example, cube root of 8 would be 2. Cube root of negative 8 would be negative 2. Cube root of 0 would be 0. But this, when it's even, you are in trouble, you see? Radical negative 4 doesn't make sense. Okay, so that's why I put the even index first. Okay, so let's continue. Move the 2 to the other side. You don't need it. The other one we have to multiply by negative. We don't need this one. Take the square root. But we talk about it. Radical x squared is absolute value of x. Greater than or equal to the radical 2. Your distance from your home is greater than radical 2. So this means you are not going home. Put the numbers on the number line. Again, this is 0. This is a radical 2, a positive. And this is a negative radical 2. You see? It's greater than. So you are not going to be within because it's greater than. So what's going to be your choices? You may go to this side, or you may go to this side. You see? Just compare them together. Less than, you are within the negative 3 and positive 3. Less inside. Greater than, outside. Outside to the right or to the left. So I'm going to read it. This is a negative infinity and this is a positive infinity. So what's going to be the domain? 2 portions. Negative infinity up to the negative radical 2, a parenthesis, a bracket, union with a bracket radical 2, and a positive infinity. That would give you the domain of the function. Okay, so that's going to be the one that we're going to have. Okay, any question? How come we don't change the sign to this one? Because we don't need it. We don't need it. We are going to find the x right away. You see, look at this one. That was a negative x squared. Negative x squared, you want to solve for x, you have to take care of negative sign. But over here, it's x squared, it's positive. Okay, so if it's going to be negative, you multiply by negative 1 so that you can do it. Okay, so over there, yes, it's a negative 1, you divide by negative 1 to find the x squared. But over here, you don't need it, it's a positive number. Any question? So make sure you know the difference between these two cases. Okay. Yes, when we multiply or divide terms of the inequality by a negative number, we switch or reverse the sign of the inequality. But when you just divide it by a positive one in this case. So that's why we didn't need it. Okay, that will end up into your question that what would happen if it's odd? You are lucky. If it's going to be odd, no restriction. So look at this one, part G. Part G, h of x is equal to cube root. Okay, is equal to the what? Cube root of x cubed minus 3x plus 7. You see, index is odd, no restriction. You can have positive, negative, whatever you like inside the radical. So index 3 is odd. You see, when it's index odd, forget about the radical. What is inside? What type of function is this one?
Polynomial.
Polynomials. And you know that the domain of the polynomials are all real numbers. Because index is odd, forget it. Then, so index 3 is odd, and so the domain, all real numbers. Negative infinity, positive infinity, or R. This function is defined everywhere. Any question? So you have to focus on the index of the radical, and you'll be given both of them. Index odd, lucky, because we have no restriction for the odd. But that's even because of the square root of those numbers. We cannot have a square root of a negative number, so that's why. Okay, so that's question number 1. We divide it into 2. We give you 2 questions of this one. Very important one. Read it carefully. As I told you, you are going to see them 3 more times. Next, limits. All the limits that I talk about it. The first one, most popular one. A limit of a piecewise defined function. We did 3 tonight, and there you are. We give you 1. That's the number 2. A piecewise defined function would be given, and they have been asked to find the limits of the function. So the function is f of x equal to, that's a function, 5 minus 2x, when x is less than 3. 1 plus 3x, when the x is greater than or equal to 3. So the function is partitioned around the 3. So you've been asked the following question, the first part. What is the limit of f of x when x goes to 3 negative? I'll just do it as I talk about it. Okay, there you are. Now you have to know it. X goes to 3 negative. What does it mean? Be quick.
X is less than 3.
X is less than 3. When x is less than 3, which part of the function are we going to use? The first part or the second part?
The first one.
The first one, that's it. We do it right away. So it's going to be limit of 5 minus 2x when x goes to 3 negative. You see, you identify which part of the function are going to use. For the rest, it's just a substitution. Okay, yes, you're right. So it's going to be 5 minus 2 times 3. Remember, this is just the sign of the direction, not the sign of the numbers. So it's going to be 5 minus 6 equal to the negative 1. This is the way you write it down. That's a left limit. Question. See, nice. Read it. X goes to 3 negative, x is less than 3. Be careful. Sometimes they may start with the 3 positive. So I have to use the first portion of the function. As long as there is an x, you put the limits. But when you substitute, you're done. Second part. They ask for the limit of f of x when x goes to 3 positive. Again, x goes to 3 positive. What does it mean?
Greater than 3.
Greater than 3. So when x is greater than 3, which part are we going to use? The first part or the second?
The second one.
The second one. So it's a limit of the second. 1 plus 3x, x goes to 3 positive. The rest is substitution. You replace the x by 3. 3 times 3, 9, 10. So the right limit -1, the left limit 10. So what do you have for the third one? In the third one, they ask, what is the limit of f of x? X goes to 3. What's the answer to that?
Doesn't exist.
Doesn't exist. And this is the way you're going to explain. You say, oh, the limit of f of x, x goes to 3 negative, is not. You have to write it down. You have to give us a reason. Is not equal to the limit of f of x, x goes to 3 positive. And that implies that the actual limit does not exist. Okay, there you are. Okay, if they are equal to each other, you say, oh, it's equal to the 9, for example, and then that limit would be 9 too. So if they are going to be equal, all the 3 limits would be equal. But if the first 2 are going to be different, we are not going to get the limit. That's it. That's part 3. Any question?
I had a quick question.
Yes.
They both have to be exactly the same, right? It has to be -1,
Yes.
-1. It can't be
Yes.
-1 and -2. That wouldn't count, right?
Yeah, they must be exactly the same. Yes.
Okay, thank you.
Okay, that's one. Part D. Part D, they ask for the actual value, f of 3. So you have to check where you can put x equal to 3. Just check. You can't do it here, but you can do it here. Okay, because we have the equality. If this equality was not given for the second one, you say f of 3 does not exist, it's undefined. But since it's given to you, substitute. It's going to be 1 plus 3 times 3, 9, 10. You're done. You see, nice problem. We like it because we check a couple of things, you know, for this problem. So that's why they like these type of problems. Limit of the piecewise defined function. What's that? Is it also because x is bigger or no? This is only because the right limit and the left limits are the same. This one, you mean? No. You see, you just check.
Yes.
We just go for the equality.
Okay.
You see, x is greater than or equal to 3. You want only equal to. So it's given to you. So you just substitute. Okay, if it's missing, you say f of 3 is undefined, does not exist. Don't say no solution. Okay, when you say undefined, this means 3 is not in the domain of the function. Okay, but we accept. So this is one of the problem that would be given to you. Okay, so that's the number 2. I'll come back to the number 3 later if you get the time. I'm going to do it later on. But I want to do those special limits that we have. I can give a quick break because I have to give you a break. So it's a 45. Okay, let's have between 5 and 10 minutes. We come back. We have to do those special limits. Remember, 0 cases. And then we finish it. And that gives you idea, the model of the quiz, if you like. You have a similar one on the take-home one. So you better do it to get these numbers. Okay, so we come back between 5 and 10 minutes, and then I do the rest for you. See you then. Okay, let's get the more on this. Okay, you want to grouping one, graphing one, I do the graphing one first for you. It's number 3. Okay, the function will be given to you. We would like you to graph it and then find the limit. I do one of them, part 1. And the function is f of x equal to is a 2x when x is less than equal to 2, and the 6 minus x when x is greater than 2. They ask to graph it first and find the limit at 2. Remember, we talked about it. For the piecewise defined function, we graph each portion separately, but in one xy coordinate. So we graph the first one, y equal to the 2x, when x is less than equal to 2. You need 2 numbers for the x, 2 values for the x. See, this is it, this is x, and this is y equal to the 2x. Your first number must be partition point, 2. And something less than 2, like 1. Okay, you start with a partition point to make sure that you are not going to go over, because that's your restriction. And then something less. So you substitute here. So 2 times 2 would be 4. And over here, 2 times 1 would be 2. Okay, now we're going to graph this part first. That's it. So you can locate the points 2, 4, x equal to 2, y equal to the 4, 1, 2, 3, 4. So that would be the end. Okay, those restriction x less than 2. This is a 2. And we talk about it if there is equality sign, you make a solid point here. And if the equality sign is missing, you make a hole. Okay, so that's the first point, 2, 4, then 1, 2, 1, 2. This is going to be 1, 2, the other point. Now you continue, since it's the left, you go to the left. So that is going to be the graph of the first part. Any question? So you must start with the partition point. Forget about algebra, whatever you do. Intercept x equal to the 0, y equal to 0 doesn't make sense, because x is less than equal to the 2, so you must start with the 2 less. If you don't pick the 2, your graph is going to be something quite different, and we are not going to accept that. Okay, that's the first portion. Any question? Pick the second part. So for the second part, the function is y equal to the 6 minus x. Restriction, x is greater than 2. Pick 2 numbers again. See, x, y equal to 6 minus x. 2 numbers, start with the partition point, 2, and something greater than, like 3. Okay, you must start with it. Don't worry that there is no equality sign. It's okay, we are going to take care of it. But we have to start with the, with bottom 2. Substitute. X equal to 2, that gives 6 minus 2, which is 4. Okay, which is going to be equal to 4. Then x equal to 3, 6 minus 3, which is a 3. You see, that is going to be the case. So go back and identify this portion. 2, 4, 2, 4. You see, since you don't have the equality sign, you have to have a, what is that? You have to have a hole, but it's already been covered by the first part. So it's going to be the same point here, okay? This graph would be continuous. The first portion and the second. That's why we pick x equal to 2, you see? 2, 4, 2, 4. So we know that this point is going to be covered again, so we have to start from here. Then you have 3, 3, 3, and the 3, 1, 2, 3. 3, 3. That's the second point. You connect and you go to the right, this one, because x is greater than 2. So this would be the graph of your function. If these two numbers are going to be different, so your graph would be disjoint, two portions. If they are going to be the same, you connect them together. At the next section, we are going to call this graph continuous, okay, to get these numbers. Yes, what's the question? Yes, it's a solid because it's already been covered.
My question is, so when we're doing like the whole like table, would we always include the number like that, even though it doesn't have the equality sign?
Yes, yes.
Always, right?
Yeah, always, always.
Okay, thank you.
Because if you pick any other number, you see, you are going to have a break in your graph. Okay, so you have to pick the same number. You see, this number is already covered. So that's, you know, you are not going to get a hole here, if you like. But if this number is going to be something else, like the second example that we have, if you get time and do it, then you know that at this point there's going to be a break. Because your function, you see, your function is partitioned around the 2. You see, it's partitioned and you're around the 2, and your graph must be also partitioned around the 2. Remember when we determined the domain of the function? So if you don't pick this number, because the 2 is already covered by the first part, so it's going to be no harm. But you must start with the partition point and you must end up with the partition point to get the good idea of the graph, okay? So as you see, they are connected to each other. Then they ask for the limit of the function. You have to find the right and the left limits and to see what's going to be the result, okay? So that's the first part. So for the second part, you have to find the right and the left limit yourself, limit of f of x, when x goes to 2 negative. You know that 2 negative means x is less than 2. And the function to be used is the first part. So it's going to be limit of the 2x. When x goes to 2 negative, you substitute 2 times 2, 4. And you already got it here. You see, that's what. And then you find the other side. Okay, so what's going to be the limit of f of x when x goes to 2 positive? 2 positive is x bigger than 2, so use the second part. So we're going to limit of the 6 minus x. When x goes to 2 positive, if you substitute, that gives you 6 minus 2, which is equal to 4. What's the conclusion? 4, 4. Right and the left limits are the same. So this means, you see 4 is equal to 4. So this means the limit of the function, limit of f of x, when x goes to 2 is equal to 4. You know that if they are different, so the limit does not exist. Okay, so since it's around the partition point 2, you have to find the right and the left limit first. You find the right and the left. If they are the same number, as usual, this is the limit of the function. If they are two different numbers, this means the limit of the function does not exist. Okay, it's like the previous problem. So your extra action is what? You're just doing the limit for us extra. Any question? So make sure when you graph it around this point, because the partition point. When you find the limits, you do the limits around this point. You see, right, left, right, left. From the graph, you know that the limits must be the same as each other, you see, because you connect them together at this point. If you get two different portions, these two limits are not going to be equal to each other. So then the limit does not exist. Okay, so it's going to be like the previous one. Any question? So that is a question regarding the piecewise defined function. Now, the other question are going to be just, we put a couple of those, a special one. Okay, so far you get 4 questions. You get 4 questions, you need 2 more. That 2 more are going to be those special limits, okay? Special limits, this is number 4. Okay, number 4, we ask you to find the limit of each function. Find the limits. And these are going to be the one that you get the 0, 0. So the first one, straightforward one. Okay, the radical x minus 3, x minus 9, x goes to 9. You know that you substitute to see what's going on. So replace the x by 9. Radical 9 minus 3, 9 minus 9. Radical 9 would be 3 minus 3, and that's going to be 0, 0, 0. What's the message? Do you remember? 0, 0. 0, 0. Very good, Paul. There is a common factor. What is that common factor? X goes to 9. So the common factor is no x minus 9. X minus 9 is a, you see, we talk about it. You put x equal to the 9 to get the 0, 0. How do you get x equal to 9? So there is a factor, x minus 9. So as soon as we get the 0, 0, there is a common factor. X goes to 9, the common factor is x minus 9. X goes to -4, the common factor is x plus 4. So remind yourself that x minus 9 is a common factor. Okay, it's going to be a common factor. So you have to find it and eliminate it. We talk about it. Since it's the radical over here, you multiply the top and the bottom by the conjugate of the radical expressions, a little bit of algebra. So we have to start it over. It's a radical x minus 3 over x minus 9. I repeat it. So it's going to be equal to the limit of. So you multiply the top and the bottom by the conjugate of the top. The conjugate means you just change the middle sign. So that's a radical x plus 3. You do the same thing to the denominator. It's x minus 9 times radical x plus 3. Okay, x goes to 9. You must create x minus 9 on the top. We talk about it. The top is going to be equal to a special product. Remember, a squared minus b squared, which is a minus b times a plus b. So the radical x squared minus 3 squared. The bottom one unchanged. Keep it as is. You continue on the top to get that common factor. Radical x squared would be x. 3 squared would be 9. Now we get the x minus 9 times it by radical x plus 3. We have the common factor, you see. If you don't get the common factor, probably you miss something. You have to go back and check it. Okay, so eliminate the common factor. You divide it, that give you 1, and this would be 1. So you get the limit of 1 on the top, radical x plus 3 down the bottom. X goes to 9. Substitute is going to be 1 radical 9 plus 3. Radical 9 is 3, 3 plus 3, 6. 1, 6, the final answer. Okay, very popular case we talked about the other night. And we are going to use it in the next chapter. Okay, so important part is just the beginning. When we get the 0, 0, the message is there is a common factor. That common factor is x minus 9. You have to find it. You already got it here. So since the radical on the top, we talk about it, you multiply the top and the bottom by the conjugate of the radical expression, by radical x plus 3. Automatically use the kind of a special FOIL method. You get the x minus 9, you eliminate it. So the final answer is 1, 6. Okay, that's a case 1. Any question? Case 2 for the 0, 0. When it's a polynomial, remember? Case 2, you want to find this limit. Limit of x minus 2 over x squared minus 7x plus 10. Okay, plus 10 when x goes to 2. Again, you substitute. You substitute to see if you can get it. So that would be 2 minus 2 You substitute here 2 squared minus 7x, 7 times 2 plus 10. Go on, the top would be 0. The bottom 2 square 4 minus 14 plus 10. 10 minus 14, negative 10 plus 10 would be 0, 0, 0 again. What's the message?
We have a common factor,
Okay, what
x
is that?
minus 2.
X minus 2, very good. X goes to 2, x minus 2. So x minus 2 is a common factor. Common factor. So since it's a polynomial, we factor it. Okay, on the top, you already got the x minus 2. So you are going to pull out the x minus 2 from the bottom. Eliminate that, substitute, you get the result. Okay, so we started over. That's a limit of x minus 2. This is x squared minus 7x plus 10. X goes to 2. That's a 10. So it's going to be equal to the top. You already got the x minus 2. So we have the common factor on the top. The bottom one factor, this one. You know that one of the factor is x minus 2. This is, you guess yourself. So what's going to be the second factor? Second factor, how we find out this is x. So this must be x to make it x times x, x squared. Then the numbers, this is a positive 10. You have a negative 2. So negative 2 times what would be a positive 10? Okay. Yes, very good. Negative 2 times negative 5. So that gives x minus 5. Okay, because x times x would be x squared, and negative 2 times negative 5 would be a positive 10. Automatically, if you multiply it, that give you, okay, the final answer. Now we have the common factor, eliminate it. The top would be 1, so you have the limit of 1 over x minus 5 when x goes to 2. Substitute to get the result. 1 over 2 minus 5, which is going to be a negative 1/3. The final answer. See, these are like the one that we did before. So you should be able to find it right away. Question? That was the type 2. Type 3, the absolute value, the one that we discussed tonight. Limit of absolute value of x minus 3 over x minus 3. X goes to what? 3 positive. See if we can do it. Remember, you have to drop the absolute value. And you have to check what is going to be inside. Is it positive or negative? We check. X goes to 3 positive. What does it mean?
It's greater than 3.
Okay. If greater than 3, what's going to be the sign of x minus 3? Pick a number bigger than 3.
4.
4. 4 minus 3 would be 1. It's positive. So since the inside is positive, remember, we just simply drop the absolute value. Is the limit of x minus 3 over x minus 3, x goes to 3 positive. That's it. If this is going to be negative, you drop the absolute value. Remember, use the opposite, negative of x minus 3. Just check one number for yourself to find out whether it's a positive or negative. There you are. You have a common factor. You simplify the top and the bottom. 1, 1. Done. If x goes to 3 negative, the result would be negative 1. I just write it down for your information. You see this one? If this is given to you. Three negative means x is less than 3, suppose 2. 2 minus 3 would be negative 1. So you drop the absolute value, but you have to apply a negative sign, negative of x minus 3. X minus 3, x goes to 3 negative. Eliminate it, negative 1, 1, that give a negative 1. It's always the same. One of them is 1, the other one is a negative 1. And you know that the right and the left limits are not the same. So the limit of this function does not exist. Okay, so this is 3 special limits. And the last type of the problems is just finding that m that we talk about it. I do one for you over here, then you should be fine, but you have to do the take home one. So number 5, we give you now 3 so that you'll be able to practice yourself. So I do just one of them. This is just the converse problem that we discussed tonight. Make sure you write it down, correctly. So what is this one? You want to find that constant m. Remember, this is the function. F of x equal to, this is a negative 3m plus 5x if x is less than 2. Answer 3m minus x if x is greater than 2. Okay, it's a piecewise defined function. Anytime you see this, find the right and the left limit. That would be 50% of the grade. But what they want, exactly the one that we did tonight. Find m so that limit of the function, limit of f of x, x goes to 2 negative, is the same as the limit of f of x, x goes to 2 positive. That's a question. Remember, we talked about it. In order to find the m, you need an equation. So I'm going to make that equation. There you are. Find this limit, the left. Find the right limits. Let them to be equal to each other. Solve for m. Okay, so find those limits first. Limit of f of x. X goes to 2 negative. X goes to 2 negative. What does it mean? X goes to 2 negative.
It would be less than 2.
Less than 2. When x is less than 2, which portion are going to use? The first part or the second part?
The first part.
The first part. There you are. Limit of negative 3m plus 5x. Now substitute. Substitute x equal to, okay, substitute x equal to 2. That is going to be 1. Yes, Paul, you're right. Okay, substitute x equal to 2 is going to be negative 3m plus 5 times 2 is going to be negative 3m plus 10. Keep this one. That's a left. Do the right. Limit of f of x. X goes to 2 positive. So you know that 2 positive means x is less, x is greater than 2. So we have to use the second part. So that gives us a 3m minus x. X goes to 2 positive, you substitute for x, 3m minus 2. That is the second part. But you be given that find m so that they are equal to each other. So make them to be equal to each other, okay? So negative 3m plus 10 is the first one. Let it to be equal to 3m minus 2, the second part. Solve for m. Solve for m. You move the m's to one side. This is a negative 3m. And you subtract negative 3m equal to negative 2 minus 10. So that gives you negative 6m, and that would be negative 12. Find the m. M is negative 12, negative 6. The result is m. Okay, m is equal to 2. And with that. You see, these are all the cases that we need to know. Okay, so these are the concepts that's going to be covered on that quiz. So you have the, these 5 part B, part C, all of them are the same. I just put all these so that you can practice. Okay, so you have various examples similar to what I did tonight. So study those, and of course you have a similar one on the take one, and then you should be fine to be able to give us. Okay, do those six questions. That's it. Any question? So study that second one. If you have any question on that one, you can email me. Okay, and you know that if you have the line, you can, if you like, if you have time, you can study those and be prepared for it. As you can see, these two sections are very dense section. So pay attention, and that would be useful for us, to know it. Which one, 6 or -6? No, it is, which one? Would it be 6 and not -6?
I think it depends how you solve the equations, but it gives you the same answer.
Yeah. Yeah,
Like
that's
if
it.
you were to add 3
Yeah,
and
yeah. Yeah, I just subtracted 3. Yeah, the answer is 2.
Okay, thank you.
Okay, that's good. Very good. Okay, any question? So study those, and then we give you the quiz at the beginning of the lecture, and we give you 1 hour. We post the quiz on the canvas. Okay, you don't have to copy down the quiz or print it. You just read the question and you answer your answer on your own paper. Make a PDF file. You go back to the canvas and you submit it over there. So this is the way we're going to give you the quiz. Okay, that's it. Have a good night and see you on Tuesday. Email me if you have any